statistics, inferential statistics. And we have also explored the meaning of population sample. The very key important two concepts, sampling distribution and central limit theorem, what that it says. Sampling distribution is nothing but what the sample we can draw from a population, n number of population we can draw, and that distribution of the sample mean is called as a sampling distribution. The central limit theorem says that the sampling distribution mean, that is an x double bar is equal to x bar equal to mu. Mu is nothing but population mean. X bar is nothing but a sample mean. X double bar is a sampling distribution mean. Standard error is nothing but standard deviation of the sampling distribution, that it can be calculated by sigma divided by root n. There is no necessity to collect the n number of samples, and from that there is no necessity to calculate the standard deviation. Simply we can take the population standard deviation, if it is a known, that it has to be divided by root n, or otherwise take a sample, calculate the standard deviation denoted by small s, that it has to be divided by root n. That represents the standard error, that is a standard deviation of sampling distribution. This is the central limit theorem says. And based on this principle only, we are trying to make an inference about the population by using the sample, right? And the various notations we have covered yesterday. What is the population parameters notations and what is the sample statistic notations, all these things. It is a universal. Wherever you are seeing the symbol, you can understand whether that it's pertinent to the population or it's a pertinent to the sample. Next one, what we have covered is an arrangement of data, unstacked data, stacked data. So both the arrangement of data is important, and predominantly we are using a stacked data for the analysis purpose, and for a presentation purpose, for a report purpose, we are using a unstacked data. Right. When we are talking about the descriptive statistics, we have covered 4 business movements: first order business movement, second order, third order, fourth order business movement. The first order business movement is nothing but measures of central tendency. In that we have covered mean, median, mode, geometric mean, harmonic mean. The mean is the one for a numeric value without any outliers. Is there any outliers? We have to apply median. And mode is for, here I have done a small clerical mistake, median. Okay, n I have to add. Please correct it at your end also. And mode is for a qualitative data, and geometric is mean for when you are multiplying the values, or it's a kind of a growth or growth of the return or anything that you are multiplying. Then again you have to apply geometric mean. When two variables are inversely related, you have to apply harmonic mean. And as well as the dispersion is concerned, range, variance, standard deviation, coefficient of variance are all single variables. Covariance and correlation is 2 variables. And standard deviation is an absolute measure. Covariance, coefficient of variance is a relative measure. Yesterday we have seen with an example relative measure and absolute measure. Both the measures are supposed to be read together, otherwise we may be misleaded. Right. Coming to the correlation, it is a standardized measure of the covariance. Standardized measure of the covariance. Right. Next one, what we have covered is a skewness. Skewness is nothing but asymmetry in the distribution. With the graphical representations, we have seen whether the teacher is a lenient teacher or a very tough teacher or a moderate teacher, that we have explored. Then next one, what we have seen is a cortasis. Cortasis, there are 3 types of a cortasis: leptocortic, mesocortic, platocortic. Platocortic is a very flat curve, and a very peaked curve is a leptocortic, and the mesocortic is a normal distribution. Right. The next one, what we have covered is an exploring data. In the exploring data, we have seen the mean plot, that it will talks about the location and whether there is a shift in the location, pattern in the locations. Okay. And is there any what is the magnitude of the location? The 3 questions can be answered with the help of the mean plot. Similarly, standard deviation plot, that it talks about the dispersion. And this also talks about shift in the dispersion, magnitude of the dispersion, and the pattern of the dispersion. clearly that it will indicate before starting the deep analysis, we have to explore the data, right? This one talks about that particular dispersion or change in the that is called as a normally I can call it as a what it's it talks about the particular dispersions, okay, and the location and the dispersions. And when we are talking about the uh, the box plot, that it covers both the location as well as the variations or in the dispersion, whether there is a shift in the location, whether there is a shift in the variance, both that it will be revealed by the box plot. In the box plot, there are 5 number summary: minimum, Q1, Q2, Q3, maximum. Thus, left whisker, right whisker, box, left side box, right side box, and the interquartile range. Interquartile range is nothing but Q3 minus Q1, right? And we have compared it with the skewness of the data, and that it gives a great insight for us. And few examples also we have seen: the meals analysis, the day wise analysis, all these things we have seen. In the naked eye we can make an inference, okay, and further we can substantiate with the statistical analysis, right? And this box plot is can be mapped with the normal distribution, and 1.5 times interquartile range. When you are subtracting it from the Q1, it's a lower bound. When you are adding the 1.5 times interquartile range with the Q3, that is an upper bound. Beyond that, whatever the data that it lies is an outlier. And within the minimum and upper bound and lower bound, the data that it lies, it's equivalent to 3 sigma distribution. Okay, right. And the next one, what we have covered is a scatter plot. When you are talking about a two numeric variables, we can apply scatter plot. The scatter plot is a one that it will help us to read the two variables movements. And next one is a dot scale diagram. This dot scale diagram is a very helpful tool to identify the outliers. How whether the data that lies within 1 sigma level or a 2 sigma level or a 3 sigma level in the detailed fashion yesterday we have covered. And followed by we have covered the histogram, and followed by bar and line chart. Already we are using it extensively. The last very important the display is a 80-20 principle, that is a Pareto principle. This will help us in a great way to identify the 80% of the results by the 20% of the efforts what we are putting forth, whatever may be the things. Is it right? This is a best example of an SBI ATM card issues. So there are two issues that it's causes the 85%, 83% of the issues. The two things that it's issues, or the what I can say, the compliance, 83% of the compliance I can say, and the remaining things are very nominal. And then again, when we are addressing these two issues, obviously we may address the 83% of the issues. And this is the kind of a Pareto charts of power. And always you can apply wherever you are, that is a reason for that particular the causes, then again you can apply this one, and then again we can take a decisions or we can take an initiatives, right? Today let us start with the scales of measurement. Before starting this session, I would like to clarify the doubts, if any, if you are having it. Yesterday I have shared the PPT. I hope all of you have gone through it. Any doubts so far what we have covered? The basics of statistics, then again descriptive statistics, and then again exploring data. In that, any doubts or any clarifications required?
No, sir.
Right, okay. Now let us start with the scales of measurement. Pardon? Somebody is asking question. I'm waiting for your reply. Are,
No,
no,
sir.
right,
I
okay,
just said
thank
no.
you. Scales of measurement is very, 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 very important one, that it will help us to decide what type of a statistical test I can apply. Sometimes you may be doubtful whether shall I apply chi-square analysis, shall I apply ANOVA, shall I apply t-test or equivalent t-test, which test I am supposed to apply. For that, the two things are very, very important. One aspect is a scales of measurement. Another one is a, then again we are covering it in the next to that one. Okay. First, let us take the scales of measurement first. In the scales of measurement, okay, before starting that, I'm asking you to make a note of it. There are four characteristics. There are four characteristics. Please make a note of it. I will also write down. Okay, I will also write down in the Word document. Just I will open up the Word document and then again I will. Okay, what I will do is I will write down. Can you see my Word document? The first
Yes, sir.
parameter, then again, I can say that identification and classification. It's the first characteristics. Identification and classification. The second characteristics is ordering or ranking or arranging. Whatever the meaning you can say. The third one is equal interval. Distance, equal distance. Whatever may be the name you may call. Then the fourth one is real origin of real origin of zero. Real origin of zero. There are four characteristics. Always we have to cross check whenever we are seeing the data. As a set of data, when you're seeing it, you have to.
So the screen.
Screen is visible.
No, sir.
I have shared the entire screen. 1 minute.
It's visible, sir.
Is it visible? Right, okay.
It
Madam,
was visible.
now it's
Now also we can see your screen, sir.
right, okay, then it's okay. It's now visible, the Word document.
Yes, sir.
Identification and classification, ordering, ranking or arranging or arrangements, equal interval, equal distance. We may call it either in the way or whatever may be the equivalent terminology you are using it, nothing wrong, and real origin of zero, right? So whenever we are seeing a data set, we have to apply these characteristics and whether the characteristics can be observed or can I identify these characteristics from the data set. Based on that, I can say that whether the data set is a nominal data or an ordinal data or an interval data. So the first I can say that ordinal data, nominal data, nominal data, ordinal data, and interval data, and ratio data. Then again I can say, okay, right. This two together, the C and D together, we may call it as scale data. This interval data and ratio data put together, I may call it as scale data. Okay, scale data. Scale data is nothing but the scale data is an interval or ratio. Either any one of that particular thing can be called as a scale data. Even in SPSS, you can see that they are using only three: nominal, ordinal, scale data. Some of the softwares are using 4 classifications. Some of the softwares are using 3 classifications. That means, then again, this interval and ratio put together, they are called as a scale data. Okay, right. Let us now see what do you mean by nominal data, what do you mean by ordinal data, what do you mean by interval data, and what do you mean by ratio data. Okay, right. Now I am asking you a question. The students' roll numbers are there. Students' roll numbers are there. Let us take the roll number as 1, 2, 3, 4, 5, 6, 10 students are there, 10 roll numbers are there. Can you add this roll number 1 plus roll number 2 equal to roll number 3? I am waiting for your response. Once again, I am repeating my question. Students are there. I am assigning the roll numbers. Roll number starting from 1 to ends with 10. The first roll number plus second roll number. If I am adding it, what is the value? Obviously, if I am using a calculator or whatever may be, that it will throw 3. Can I say that the roll number 1 plus roll number 2 equal to roll number 3?
Yes, sir.
Yes?
Yes.
But then again, 1 plus 2, 3. But can I say that it represents the third roll number student? Roll number 3.
No.
No.
No, sir, we cannot.
Yeah, that is a common sense with which we can. But that numbers can be added together, but there is no meaning of it. There is no meaning of it. I can't add this roll number 1 plus roll number 2. So let us take another example.
No, sir.
Football players. Football player number 7 plus 8th player. 7th player plus 8th player equal to 15th player. Can I say like this? No. Obviously, it is a common sense. But what is the purpose of 1, 2, 3? What is the purpose of 1, 2, 3?
Identification, sir.
Yeah, identification. See here, that is a first property. Even though we are using a numeric values, okay, simply we are using that particular numeric values for identification purpose, so that never I can't add. There is no meaning of it. Okay. Say one example, then again I can say that hypothetically, let us take like this. Okay, so I will take one Excel sheet, and then again I will mark it. Okay, 1 minute. I will showcase to you for demonstrating purpose. Okay, right. Excel. See the roll number 1. Let us take roll number and marks of the students. Okay, roll number and marks of the students. My Excel sheet is visible now. Yes. This is a
Yes, sir.
roll number. This is a marks. Okay. And roll number, I am taking it. Roll number 1, 2, 3, 4. I am taking it. Hypothetically, I am taking some of the values here. 10 data. I can take 10 data. Okay. The roll numbers, I can take it as like a 100, 90. Sorry. Here, yeah, 100, 90, 80. Like hypothetically, I am taking it. If I am correlating these two values, probably I will take a -1. The correlation value is -1. The correlation value is a -1. Okay. Appa, what does it mean? Meaning, higher the roll number, lesser the roll number.
Lower the score.
Higher the
score.
roll number, lower the score. Is it right? That is the meaning of it. Is it right? Is it right? Can I do the correlation analysis with the roll number and marks?
No.
No.
There's no association.
Yeah.
No, sir.
Because we have to apply the common sense here. See the roll number here, even though it is a numeric value, that it's only for the purpose of identification purpose, so that I can't use it in the correlation analysis. That knowledge we are supposed to have it. Similarly, we may have a gender, female, male. What is the purpose of pointing it as a female, male? What is the purpose of it? Students are there. I'm grouping the people by gender, male, female, hostlers, day scholars, commerce graduate, science graduates. Like I'm classifying it. See, the other purpose of this nominal data is a classification. When the data for the purpose of identification or a classification only that it serves the purpose, then again it is called as a nominal data. Can you now order it? Can you now order it? The roll number 60 is greater than roll number 1. Can you say? Can you say that the female is greater than the male member? Can you say that the hostler is better than the day scholar? Can you compare and can you order it?
No, sir.
Ordering is not possible. So in the nominal data, you can have only the identification and classification property alone. You didn't have you don't have the property of a ordering. You don't have property of an equal interval. You don't have property of a real origin of 0. Here in the roll number, there is never can't say that it's a 0. Or even in the male female, you can't give it as a 0 something. So there is no real origin of 0. Okay. So the 3 properties are missing in the nominal data. So only one property. Only one property. What is the only one property? Identification. Identification and classification. Classification only. You can say strongly. Right. The ordinal data is the next category. The ordinal data is a one that it will help me to identify the data, classify the data, and not only that, I can order it. I can order the data. I can order the data. Ordering is possible. Let us take one example in the Excel sheet itself. Say, let us take rank. The first rank carries marks of 90. Okay. Then again, the second rank carries a mark of 80. The third rank carries a mark of 60. Right? Okay. Can you now order it? Who is the best? Or I have mentioned it as a rank 1, 2, 3. Or the students are there 90. The guy who got a 90 marks, 80 marks, 60 marks, I am making it as an order 1, 2, 3, rank 1, rank 2, rank 3. Is it sensible? Can you order it?
You can order, sir.
Yeah, order possibly. And what is an interval between the first rank and second rank? What is an interval between the first rank and second rank? The difference or the interval? 10. And what about the second rank and third rank? What is an interval?
20.
20. See, even if the third rank is of 40 marks, the difference is 40. The interval is 40. So the intervals are not equal. The intervals are not equal in the ordinal data. And also, there is no real origin of 0. So the ordinal data, it's have a property of identification, classification, okay, identification, classification, and ordering, okay, and ordering, okay. Where I am making a mistake, identification, classification, F5 I am supposed to. Ordering is possible. But what is the missing here? Equal interval is missing, okay. And the real origin of 0 is missing here. It's up to this. It's okay. Everybody is comfortable. Let us move to the next one. Yeah. The interval data. First, I will give an example in the interval data. Fahrenheit and centigrade is the best example for an interval data. In the Fahrenheit, 0 degrees is somewhere else. In the centigrade, the 0 degrees is somewhere else. Okay. Right, the position is totally different. But this Fahrenheit and centigrades have an equal interval. So 40 degree centigrade, 40 degree, 30 degree, 20 degree, the intervals are equal, but the origin of 0 is an arbitrary. The origin of 0 is an arbitrary. One particular state of a climate or a then again context in which we are saying that it's a 0 degree. 0 degree means we can't say that then again the temperature is not, there is no temperature at all. There is no temperature at all. One example then again I can quote here. Another example I can quote, just on baby shop, when you are going for a purchase of shirts or then again the baby's gown or something, they will start with the size 0. 0 size means, do you think that then again nothing? No, they are saying that a particular size is a 0 size. Okay, so the chapel size, shoe size, these are all the arbitrary 0 that it carries. So the interval data is a one that's have 3 properties. The first property is an identification. The first property is an identification, classification, okay, and ordering is possible. And what is the thing? Equal interval. Equal interval. And what is missing here? The real origin of 0 is missing here. Index number. Index number is the best example. Then again, Likert scale. I can say that the Likert scale, highly satisfied, satisfied, neutral, okay, dissatisfied, highly dissatisfied. See here, this is a Likert scale. The Likert scale, what I can label it like a highly satisfied to highly dissatisfied. The coding I can give it as a 5, 4, 3, 2, 1. This is a one type of a coding. Or alternatively, I can give a coding like a 2, 1, neutral carries 0, and this is a -1, and this is a -2. This is a one type of a coding. Both are correct. Both are correct. This is a Likert scale. This is a Likert scale. In the Likert scale, the labels are highly satisfied to highly dissatisfied. The codings, you can give it either this way, 5, 4, 3, 2, 1, or 2, 1, 0, -1 and -2. The 0 that it indicates a neutral, and here the 2 indicates highly satisfied, 1 indicates satisfied, -1 dissatisfied, -2 highly dissatisfied. Is it okay? Would you now understand? This is an example of interval data. So temperature is an interval data, index number is an interval data, then again shirt size, shoe size. Okay, these are all the interval data. Likert scale is an interval data. Okay, n numbers, then again we can code it for an interval data. In the interval data, what is missing? Real origin of zero is missing. Arbitrarily, we are fixing the zero, but the intervals are equal. You can order it, you can identify, you can classify, you can order it, and all properties, three properties are applicable. But what is the only one property that is missing? Real origin of zero. Are you comfortable now? Yes or no? Yes or no?
Yes, sir.
Right. The ratio data, obviously, I can say that it covers identification, classification, ordering, equal interval, and real origin of zero. It is not an arbitrary zero. Kilogram, all metric measurements, kilogram, height, weight, liter, gallon, ounce, whatever may be the measurements, metric measurements, that have a real origin of zero. Never you can't say that 5 kg equal to 0, 10 kg equal to 1 kg. Like, you are not fixing it. The zero means really it's a null value. Okay, that is the ratio data. Okay, right. So the ratio data carries all four properties. Interval data carries only 3 characteristics. Ordinal data carries only 2 characteristics. Nominal data can have only 1 characteristics. Okay, are you comfortable with these examples? Yes.
Yes, sir.
Right, now I am asking one question. Please tell me whether that particular question generates a nominal data, ordinal data, interval data, or a ratio data. The number of fans in the classroom. The number of fans in the classroom. It's a question. Identify the number of fans in the classroom. I am putting a question. Okay, your answer may be anything, depends on that particular the fact. Okay, can you tell me this particular question generates a nominal data or an ordinal data or an interval data or a ratio data? Come on, don't worry, don't bother about it.
Data.
Pardon?
Interval.
Interval
Nominal
data.
data, sir.
Nominal data. It's a
Nominal
range.
data.
Nominal data. Right, okay. Somebody says nominal data, somebody says ordinal data, somebody says interval data. Right, okay. Number of fans. In the classroom, there is no fan at all. What is the value you will fix it up? How many fans you will record?
0.
0. Right. If the class contains 2 fans, what you will record? 2. Obviously 2 fans. 1 fan or 3 fan, whatever may be the. See, the distance between the 2 and 3, 1 and 2 are equal or it's a different? Equal. That 0 is a real origin of 0 or it's an arbitrary 0? The 0, what you are
It's a
fixing
real
it,
origin.
it's a real origin of 0 or it's an arbitrarily you are fixing 0?
It's a real origin, sir.
Yeah. Then if it's a real origin of 0,
Then it is
obviously you
ratio.
have to ask the
Then
question
it
from
is
the
ratio
bottom.
data.
Ratio data, that's all. You have to ask the question from
Yes,
the
sir.
bottom, so that it's very easy. If there is a 0, there is a real origin of 0, immediately you can conclude that it's a ratio data, because all other properties are obviously that it will fall. If it is a missing, you have to go to the next question, whether it's an equal interval. If it is a missing, you have to go to the next level, whether there is an ordering is possible. If it is a missing, then again you have to ask the first one, can I identify it, classify it? That's all. See, my dear friends, in the Likert scale, see, I'm fixing the arbitrary 0. See here, this is my arbitrary. I'm fixing it arbitrarily. See here, I'm fixing it 3 as an arbitrary value. These are all my fixation. I'm saying that the 3 is a neutral. I'm saying that the 0 is a neutral. But in the number of fans in the hall does not mean that if you are saying that it's a 0, means 5 fans are there, 10 fans are there. Like, you are not fixing it. So you are saying that the 0 means here there is no arbitrary 0. There is a real origin of 0. Okay. Are you comfortable now? Yes or no? Hello?
Yes, sir.
Right, okay. Now I'm asking another question. How old are you? I'm asking question. Tell me in number of years. This is a question. Okay, I'm asking a question. Probably you can say that my age is 35 years. Suppose if it is a just born baby, when you're asking this question, okay, the baby can't answer, but the mother can answer it. How old that the child is? Completed years means what they will say in completed years. Just born baby, 1 month baby. Imagine you are asking a question: how old or how many number of years the baby has completed? You are asking question. What you will record?
0.
Zero. Yeah. Whether it's a zero is a real origin of zero or it's an arbitrary zero. Whether this zero is a real origin of zero or an arbitrary zero.
Real
Arbit
origin.
real. If it is a real origin of zero, this question that generates what type of a data?
Ratio data.
Ratio. Very good. That's all. See, when you are designing a questionnaire, the way you are asking the questions will decide whether your collected data falls into the category of a ratio or an interval or a ordinal or a nominal. That is a crucial part we have to understand. Right. The same question, I'm asking it in a different patients. Please specify, please specify in which age category are you falling? Are you falling? I'm asking question. Okay. This is a so less than 20 years, less than 20 years. Okay. Greater than or equal to 20 years, but then again less than 40 years. Okay. Then another one is greater than or equal to 40 years. Okay. But less than 60 years. Okay. And greater than or equal to 60 years. What is the question I am asking? Please specify in which age category are you falling. Probably which one you will choose based on the age. Please tell me. Anyone, please come forward. Come on. In which
Greater
category?
than or equal to 20, less than 40.
Yeah, you are picking up this particular question. This is a yes, you are saying. Right now, tell me this particular question generates a nominal data, ordinal data, interval data, or a ratio data. Come on, tell me. Please ask a question.
Nominal data.
Nominal data. Right now, I am asking you one question. Can you say that the less than 20 years are youngsters as compared to greater than or equal to 60 years? Youngsters, elders. Can I order it? Less than 20 years are
Yes,
two
sir.
youngsters. 20 to 40 years are all moderately youngsters. 40 to 60 years are olders. 60 above greater than 60 years are very senior citizens. Can I order it appropriately?
Yes, sir.
If that is an ordering is possible with the common sense, you can't say that it's a nominal. It is an ordinal,
So
right?
this is interval data, sir.
Right, okay. Now, what is the property of the interval data? Equal interval supposed to be there. Less than 20 years, what is the bandwidth of the age? 0 to 20. And 20 to 40, again 20 years. Okay, well and good. 40 to 60, again 20 years. But what is the last one? Greater than 60 years means? It's not equal interval. It's an open
Okay, it
one.
can be anything beyond that. Yes, sir.
It then so it's there is no equal interval. If there is no equal interval, you can't say that it's an interval data.
Yes, sir.
Okay. Then again, this
Got it,
particular
sir.
questions fall under the category of ordinal data. By practice, then again, you can acquire the skill set. Now, even now onwards, whenever you are seeing things, you can ask a question. Suppose, say, for example, you are traveling in a bus. Okay. Then again, you are starting to count the number of buses that it crosses opposite travel. Okay. And you are starting to count the data. Okay. Right. What is the type of data are you generating it? Nominal, ordinal, interval, ratio. Just you are counting the number of buses that it crosses opposites. You are traveling towards your home. Okay. And whatever the bus that it crosses opposites, you are counting 1, 2, 3, 4. Like then again, you are counting. Is it right? Okay. And this particular process ends with a nominal data, ordinal data, interval data, or a ratio data. Come on, tell me. Come on.
It should be nominal, sir. It should be nominal, I think, because
Right.
we are
Okay.
counting.
Right.
There is
Okay. Imagine. Opposite sides, there is a no traffic at all. They have banned. Imagine you are traveling, none of the bus has not crossed. What you will record it in your record book? You will
Zero.
say 10 buses.
Uh,
How many buses you will mention? Imagine the opposites, the police stopped the traffic. None of the bus has not crossed. What is the number you will record?
Zero.
Zero. Whether it's an arbitrarily, are you fixing zero?
Because no buses have crossed. So it
Yeah,
should
it's
be
an obvious. Even if we are hearing that none of the bus has not crossed, you will record it as a zero. If anybody else is also hearing that particular information, they will also record it as a zero.
obviously.
Then again, it is
Yes.
a real origin of zero. It is not an arbitrary zero. You are saying that the 5 buses crosses, I will say 0. 10 buses crosses, I will say 1. 15 buses crosses, I will say 2. Are you saying it in such a fashion? No. If none of the bus has not crossed, you will say 0. If 2 buses crosses, you will record a 2. If 3 buses crosses, you will record 3. So 2 buses, 3 buses, the interval is equal interval. 3 buses, 5 buses, interval is 2. 5 buses, 7 buses, the interval is 2. Interval is equal. Real origin of 0, equal interval. 3 buses is lower than the 5 buses. It's an ordering is possible. Common sense with which we can order it. Identification. Yes, obviously, all the things have an identification property. So it is a ratio data. It is a ratio data. See, whenever we are learning the statistics, miserably we are failing to understand the type of data. Okay, so based on the type of the data only, we can decide the statistics. Otherwise, what will happen? What is the correlation we have done it here? What is the correlation we have done it here? What is the conclusion? Higher the roll number, lesser the marks. Meaning, if the guy is having the Z as a starting letter, always will have a lower mark. The guy who is having the AA, the word, the name, always will secure a higher marks. Is it right? Is it appropriate? The conclusion is appropriate?
No.
See,
No, sir.
whether shall I apply correlation? Common sense we have to apply. It's a simple common sense. That's all. There is no rocket science here. So always please keep it up. The 4 questions: identification and classification, ordering, equal interval, real origin of 0. Okay. So when you are well versed with this one, immediately you can conclude that the given data set is a ratio data, so that I can apply this test. Right? And one more thing, always you have to keep it in your mind. Whatever you are applying for a real, scale ratio data, you can't apply for a nominal data. You can't apply for a nominal data. Once again, I will repeat it. 1 minute. Okay. I'm taking my epic pen. Now I have separated the epic pen. Then 1 minute. So here, whatever you are applying for a ratio data can't be applied for a nominal data. Okay. See here, whatever you are applying for a nominal, I'm starting from the beginning. Whatever you are applying for a nominal data, you can apply for a ratio. Whatever you are applying for a nominal, you can apply for a interval. Whatever you are applying for applying means the statistical test. I'm saying that applying for a nominal data, you can apply for a ordinal data. But whatever you are applying for a ratio can't be applied for nominal. Vice versa. Whatever you are applying for a ratio can't be applied for a ordinal. That it can't be applied. Whatever you are applying for a ratio data can't be applied for a ordinal. Okay, this is an application of statistics. Second thing, the ratio data can be converted into nominal. this data can be converted into nominal. This ratio data can be converted into nominal. This ratio data can be converted into ordinal. This ratio data can be converted into an interval. But never you can't convert the nominal data into ratio data. Never you can't convert. So based on this, what is your preference of the data? Which one you will prefer always while you are conducting research work? Come on, tell me. Your preference is a ratio data or a nominal data?
Should be ratio data.
Yeah, should be. First, we have to prefer the ratio data. It is not possible. Then we have to move to the interval. It is not possible to collect the interval data. I have to think of the ordinal data. If it is not possible, I have to think of the nominal. So the nominal data is the least preferred data type, and ratio data is a very highly preferred data type. Are you comfortable now? Yes or no?
Yes, sir.
Right, okay. Now I am taking you to the slides. See, whatever I have mentioned in the slides, this one, nominal, ordinal, interval ratio. The nominal carries only identification and classification. Ordinal only have an ordering. In addition to that, identification and classification is also possible. Can be ordered in an ascending order or a descending order. Interval data have an equal intervals between the observation, and not only equal intervals, that it can be ordered, that it can have an identification and classification property. The ratio data have a real origin of 0, and not only that, that's have an equal interval, that's have an ordering property, that's having an identification and classification property. Okay, right. The next one is the next one is the examples. Let us see the examples. Employee ID, PAN number, student roll number, gender, car type, product model, etc. or example of a nominal data. Ordinal data, rank, age group, income group. I'm using the word income group. Similar to the age group, you can go ahead with an income group also. You can ask a question straightforward, what is your exact income? You can ask. If it is an exact income, if you are collecting from the respondent, that it will fall under the ratio data. If it is an income group, if you are talking, that it will fall under the ordinal data. Years of study, these are all the ordinal data. Interval data, Fahrenheit, centigrades, shirt size, shoe size, stock market index, Likert scale, rating scale, index number, etc. Ratio data, all metric measurements like a kilogram, liter, height, weight, salary, exam marks, sales, expenditure, whatever may be, all metric measurements, whatever the measures that have a unit of measurement, standard unit of measurement, that is called as a metric measurements, that's called as a ratio data. Okay, right. Are you clear now with these examples? Yes?
Yes, sir.
Right. Now, this is the same one then again I have asked and I have demonstrated also. What is your age? If you are asking, that it will fall under the category of ratio data. In which age category are you falling? That it will fall under the category of a ordinal data. Right. Now, I'm coming to the very important point. The nominal and ordinal data, you have to always apply non-parametric test. Somebody has asked about the non-parametric test yesterday. Is it right? So, whenever your collection of data that it belongs to the nominal and the ordinal, you have to apply non-parametric. You can't apply the parametric test because you can't add the two roll numbers. Roll number 1 plus roll number 2 equal to roll number 3. You can't add. So the entire calculation methodology is totally different when the data is a qualitative data. So at the time you have to apply non-parametric. And not only that, when some of the assumptions has not been met, even though the data is a numeric data, the assumptions has not been met, I have to apply non-parametric test. Okay, once again I'm repeating, if the data pertinent to nominal ordinal, you have to apply non-parametric. Even though the data is a ratio data, but the sum of the assumptions has not been met, you have to apply non-parametric. If the assumptions has not been met. If it is a ratio data, if the assumptions has been met, you can apply parametric data. Okay, clear now? Yes or no?
Sir, sir, I had a question.
Now, yeah, ask me, madam.
Sir, could you give some examples for that conditions not being met?
Well, madam, please wait. I will say the conditions in the
Sure.
subsequent slides. Then again, I have included. Time being, please keep it wait, and then again, let us explore that. Here in this particular juncture, please learn nominal and ordinal data means we have to apply non-parametric. Ratio data means we have to apply parametric in general.
Parametric.
Okay, right.
Yes.
Time
Sir.
being, please keep it
Okay.
aside, and then again, let us further explore. Right. I have
Sure, sir.
included it in one of the slides also. Okay, right. Now,
Okay, sir.
let us
Thank you.
move to the next one. See, in the measures of central tendency, yesterday we have seen, is it right? If it is a nominal data, what is the measures of central tendency you have to apply? What is the measures of central tendency? Anyone can say? What is the measures of central tendency you can apply if it is a nominal data?
Mode, sir,
Mode
because it is
only.
qualitative.
Yeah. And there is no measurement for a dispersion. If it is a no measurement for a dispersion, okay, then again, obviously that skewness is also not appropriate and it's only mode, that's all. Okay, right. The next one is an ordinal data. If it is an ordinal data, what you can apply? Median. And what is the dispersions you can apply? Range, that's all. If it is an interval data, mean. And variance standard deviations you can apply. Suppose it is a ratio data, you can apply geometric mean, harmonic mean. Meaning here, you can apply here. If it is a ratio data, you can apply mode. You can apply median. Okay, you can apply median. You can apply mean. You can apply geometric mean. You can apply harmonic mean. All measures of central tendency you can apply if it is a ratio data. Whatever it's applicable for a nominal is applicable for ratio, but whatever applicable for a ratio is not applicable for nominal data. Very, very important. Whatever you are applying it for a ratio can't be applied for a nominal, but whatever you are applying for a nominal can be applied for a ratio. Okay, so ratio data means here I mentioned only geometric and harmonic mean. That does not mean that you can apply only geometric and harmonic mean. You can apply mode, you can apply median, you can apply mean, you can apply geometric mean, harmonic mean, all the things you can apply. Okay, could you now understand? And ratio data, you can apply coefficient of variance in addition to that range. Okay, variance, then standard deviation and coefficient of variance. If it is an interval data, you can apply only variance, standard deviation. If it is an ordinal, it is a range. So this understanding will help you to choose appropriate measures of central tendency. And not only that, my dear friends, that's applicable the dispersion also. See, I have given it the tabulation. Okay, please see the tabulation. Okay, I have given the chart. Okay, I have given the chart that it will help you leisurely. Please go through it. And this is the statistics applications. Basic characteristics, common examples, marketing examples, permissible statistics I have applied here. Okay, if it is a nominal data, you have to apply for chi-square binomial test. If it is an ordinal data, rank order correlation, Friedman test, ANOVA, Friedman-ANOVA is a parametric test. Just then again, I have mentioned the name. Here I am not talking much about the test. Just this is a ready reckoner for you. If you have gathered the ordinal data, what is the type of a test you can apply? If it is a ratio, what? See, my dear friends, I have mentioned, as I rightly pointed out, I have mentioned only one. But if it is a ratio, it is not only this one. You can apply this. You can apply from the nominal. You can apply from the ordinal. Whatever you are applying for an interval, ordinal, nominal, you can apply it for a ratio. You should have a clarity about it. So because I have not included everything. Okay, right. Is it okay, my dear friends? Are you comfortable?
Yes, sir.
Yes, sir.
Right, okay. Now let us move to the next one. In this part, are you having any doubt? Shall we have a small exercise?
Yes, sir.
1 minute.
Yes, sir.
But I am facing a problem. I'm not able to see the screen. Nothing
Yeah,
is
1 minute.
visible. I'm
1
just
minute.
able to.
I have disconnected. 1 minute. I'm opening up the file and then again thereafter I will show it to you. Wait a minute. One minute. At present, then again, I thought of it. 1 minute. Just a minute. I'm opening the file. Okay. This will give a complete picture about it. I will share this 2 files also for you. Okay. And right. Yeah. Now I'm sharing it. Now visibility is there. My window.
Yes, sir. Now it is visible.
Right. Okay. This is an exercise for practicing purpose, especially to fine-tune our thought process about the types of measurements. Okay. The following informations you are
Hello.
applications for the home mortgage loan, the State Bank of India. Okay. You have collected some of the informations. Now tell me each and every type of data what you have collected that it belongs to nominal, ordinal, interval, or a ratio. Okay, one by one. Then again, let us go quickly. We can spend 5 minutes so that totally it's 15 questions are there. 5 to 10 minutes we can spend, and thereafter we can move to the next level of learning. Place of residence you are asking. He is saying that the BIT staff quarters. What is the type of data are you generating it? Come on. Come on, guys. You are asking question, okay, and you are collecting information. So one of the respondent, he has given the example. What is the thing? Yeah, come on.
Nominal data, sir.
Nominal data. Why you are saying that it's a nominal?
So because if the place is changing, it will not affect our answers or it will not affect our analysis. Whether it's Uttarakhand, whether it's Himachal, anywhere.
It is classification, identification and classification.
Yeah.
Okay.
Yeah.
Right. Type of residence, single family, double bedroom house. You are asking another because you are sanctioning a home mortgage loan. Okay. And then again you are now asking questions. Okay. Type of residence you are asking. What is the type of? Okay. Come on, tell me. Type of residence you are asking. The answer is a single family double bedroom house. The Ram Prasad is answering the question. Whether this particular output belongs to nominal data, ordinal data, interval data, ratio data. Don't worry, don't bother about it, whether right or wrong. What that strikes in your mind, please tell me. Then only you can correct yourself. Nothing wrong. Initially, when we are learning, always the mistakes will happen. Don't worry. Don't bother about it. We may correct ourselves. That's all. Nothing wrong. Type of residence. Now I am asking question. Is there any real origin of zeros there? No. Zero is not at all associated with this one. Equal intervals? No. Ordinal this can I order it? Can I order it? Single family double bedroom house and single family triple bedroom house. Can I order something?
It is
Sensibly, can you order it?
You can order.
increasing. It's increasing.
You can order.
It is a
Single.
Yes.
single bedroom that we can order it. Okay, very good. We can order it. So, because see, we have to apply some common sense. That's all, my dear friends. We have to apply common sense. That's all. Okay. So, simply then again, we have to apply the common sense, and then again, with which then again we have to come to conclusions. Okay. So, it is an ordinal data. So, please ask a question. Please ask a question that it will help us to decide whether it is a nominal data, ordinal data, or a interval data. Okay, right. See here, 1 minute, then again I have. Okay, 1 minute. Yeah. Now visibility is there. Right. This is an ordinal data. Let us make it as an ordinal one here. This is an ordinal data, right? Date of birth. Now you are asking a question. The guy is giving a date of birth. It's a tricky one. Yeah, tell me whether it's a real origin of zeros there. When the date that it has been started, from where the date has been started, can you understand the dating system? That is a calendar system. BC. What is a period? We are classifying before
BC and AD, sir.
Yeah, that's all. And then again, whether it's an arbitrary or whether it is a real, we are starting.
It is arbitrary.
So arbitrary. Obviously, then again, the date of birth or the date is not a ratio data. The date is not a ratio data, right? Between one day to 2 days, 2 days to 3 days, the intervals are equal.
Yes, equal, sir.
Equal. So it is an interval data. Okay. It's very simple. Please ask questions. Apply your common sense. Ask questions. Whether real origin of zero is there, equal intervals are there, ordering is possible. And see, in the double bedroom, you have mentioned it. Type of residence. Oh, double bedroom means triple bedroom. When I'm collecting the data, double bedroom, triple bedroom, single bedroom, can I order sensibly? Yes, I can order it sensibly. So it is an ordinal data. Okay. Are you owning a house? If you are asking a question, yes, I'm owning a house. I'm not owning a house. If that is a question, it is only a nominal data. It is not an ordinal data. It is not an ordinal data. Please understand. Okay. So monthly salary, come on, quickly, can you say?
Nominal data, sir.
How can you say that it is a nominal data?
Sir,
Suppose if you didn't have any salary, what you will record?
0.
Yeah. So then again,
So this is ratio.
This is a ratio data. Yeah. Please make a mistake. Then only you will learn. Don't bother about it. Don't shy about it. Please practice. Otherwise, you can't be master in that particular statistics. Always we are struggling in that one. Because, see, ultimately then again I have to apply test, whether I have to apply chi-square or a t-test or a correlation, rank correlation or a Pearson correlation. Which test I am supposed to apply? Always we are struggling. Always we are failing. Because of that particular lack of understanding of this particular scales of measurement. Okay, don't bother about it. Come on. Other income, you are saying that. Suppose if you are not having any other income, what you will say? What you will say if you are not having any other income? Come on, background noise is there. Don't worry. Come on, please. Whether it is
No income, it will be 0, sir.
Again, it should be ratio only, sir.
Again, it should be a ratio 1, right? Occupation. Occupation.
Ordinal data.
Ordinal data. Why it is an ordinal data? Answer is very right. Why it is an ordinal data? Why it is an ordinal data? Yeah, correct. Your answer is right. Why it is an ordinal? Why it is not an interval? Why can't? Obviously, it is not a ratio data, but why can't it's an interval? Right, okay. Professor, senior assistant professor, senior assistant professor, associate professor, professor. The experience of the each cadre, whether it's an equal.
No.
No.
No,
Need
sir.
not be equal, sir.
Need not be equal, so that it's not possible to be an interval data. Please apply your common sense. That's all. It's not a rocket science. It's a common sense only. Right.
Yes.
Coming to the employer. I'm saying that my employer is a Bangalore Institute of Technology Trust. What is the type of data you are generating here from this question?
Nominal data,
anyone?
sir.
Nominal.
Nominal
Very good. Nominal.
data.
Nominal. Very good. Very good. Very good. Then number of years at job.
Interval.
Interval. Suppose if the number of years at the
It
job.
can be ratio also, because
It's not can be. It should be a ratio data.
Yes.
It should be a ratio data.
Right.
Because the number of years completed at the job, if you have not completed a year, what you will say? If you have not completed a year,
It will
just
be
now,
zero,
then again,
sir.
yeah, it's a
will
zero.
be
So
zero.
it's a ratio data only. Right. Number of jobs in the past 10 years. Number of jobs in the past 10 years. Suppose if you have not at all employed, what you will say?
Again, it will be ratio.
Again, it is a ratio. Suppose if you have not employed, what you will say? 0. If you have employed, you may say 1 or 2 or 3 or 4. Okay, right. What about
in some of the softwares, there is only one data, scale. I mean,
Pardon?
there are three. In SPSS, in some of the softwares, there's only three data, nominal, ordinal, and scale. In that case,
madam.
interval and ratio.
Interval and ratio
Right.
put together, they are called as a scale data.
Yeah, that's it.
But normally, then again, we can classify it as a 4 category. And
But if it is not available in the software itself, then we'll be putting up in the scale one.
see,
Because I've seen softwares, there are only 3 dimensions. So.
Yes, madam. That is the reason why I have mentioned it in the beginning itself in the Word document when I am writing down. Then again, I mentioned as a scale data. See here, this is scale data.
Yes.
Interval and ratio put together, we are call it as a scale data.
Scale data.
In the social science, interval and ratio data, we are not making that much of a difference in social studies. But in a science, interval data and ratio data is totally 2 different type of a data.
Right.
And
basically,
yes, madam. Yes. Right.
Yeah, basically we are from social sciences, so we know only one.
Yeah,
so
right.
that is why I'm telling you.
Nothing wrong. Equally, you can treat the interval and then the ratio data, but preferably go ahead with the ratio data. Okay. Right. Okay. Marital status. What is the type of data are you generating? Nominal data. Very good. And number of children's.
It will be
Ratio. Very good. The loan requested. The loan amount requested.
Ratio.
Suppose if you are not at all interested in the
it can be ratio.
It can be. It should be a ratio.
It will be. It will be.
The term of the home loans. The terms of the home loan. Suppose if you are not
Again, ratio.
Again, ratio. This is the ratio. Other loans are availed. Other loans availed. You are asking.
Nominal data, sir.
It's a nominal data because the car loan is better than the jewel loan is better than you can't order it. Okay, so this is only an identification or classification purpose. It's a nominal data. So nominal data. Okay, and the amount of the other loans.
Ratio
amount
data.
of the other loans. Ratio data. Right. Okay. See, when you are designing an application form, or when you are designing a questionnaire, or when you are gathering information, or when you are collecting the secondary data, this knowledge always you should have it in your mind. Always you have to prepare a ratio rather than the ordinal. Prepare an ordinal rather than the, prepare an interval rather than the ordinal. Prepare an ordinal rather than the nominal. At the worst case, you can pick the nominal data. Okay. I hope that you have done a wonderful exercise. Now, hereafter, ask questions whether that particular questions generate an ordinal data or an interval data or a ratio data. Please cross-check with these 4 questions. Classification and identification, ordering, equal interval, real origin of 0. Please always ask from the bottom, real origin of 0. That is the first question you have to ask always. If it fails, then only you have to move to the next one. equal interval. If it fails, then only you have to move to the ordering or ascending order or descending order is possible or not. If it is not possible, then only you have to move to the identification and classification. Okay, please go up with the bottom to top approach. Okay, right. Shall we move to the next one?
Yes, sir.
Yes, sir, please.
Madam?
Yes, sir.
Right.
Yes, sir.
Now, it's a sampling technique. It's a very important part of that particular research methodology. Whenever you are writing a research paper, you have to say that research design is a one part. Research design, under that, the research methodology, under the research methodology, research design is a one component, sampling techniques is a, or sampling design is another component. Sampling design is another component. Okay. Even I can say that this particular title, even I can fine tune it as a sampling design. Sampling design. Sampling design. Okay. Sampling design, research design. There are two major components of the research methodology. Sampling design, already we have learned about it. Why statistics? The statistics allows me to take a sample from the population, make an inference about the population. Allows me to take a sample and describe about the population. So that is the reason why we are applying statistics. For that sampling design, how can I take a sample? I have to take a sample in such a way that it's a representative sample. If miserably fail to take an appropriate sample, you can't make an inference about the population. Miserably, you will fail in the purpose. So sampling techniques is very, very important. In the sampling design, my dear friends, once again, I would like to make a small correction. See here, here it is not a sampling technique. Sampling techniques is one among the sampling sampling techniques, one among the component of the sampling sampling design. Okay, and here, my dear friends, the sampling design contains, you have to first define the population. Then you have to decide the sample size, sample frame, and sampling technique. Already you have learned about the sampling technique. Sampling technique may be a probability sampling, non-probability sampling. The probability sampling may be a simple random sampling, cluster sampling, stratified random sampling. I'm not going in detail about that particular, the types of sampling techniques and all of the things. Okay. I'm here keen on sample size determination. Sample size determination. What is the size of the sample I have to draw so that I can make an inference about the population? That is a crucial part. Okay. So here, in this particular formula, see here, in this particular formula, the sample size. How can I decide the sample size? This is a formula. This is a variance of the population. This is a level of, that is a confidence level. This is a confidence level. What is a confidence level with which you would like to make an inference? D square is nothing but what is an accuracy level with which you would like to make an inference about the population or describe it about the population. This is a, D is nothing but it's an accuracy level. Sigma square is nothing but it is a variance, and Z square is nothing but it's a confidence. What is the confidence level with which you would like to make an inference about the population? Right. With this formula, imagine the accuracy level and the confidence levels are same. If the variance is going up, the numerator value goes up, what will happen to the n? Come on, tell me. It's a common logic. See here, the variance is 10, the confidence level is 0.196 whole square. Okay, 0.196 whole square. The accuracy level, what you are saying is a 2 whole square. Okay, these two are constant. These two are constant. Okay, the two are constant. Okay, the two are constant. And this 10, instead of a 10, it becomes 100. The variance become 100. What will happen to the n? What will happen to the n? Come on, tell me. What will happen to the n? What will happen to the n? If the variance goes up, rest of the things are all constant. Imagine what will happen to the n, whether the n will goes up or whether the n will comes down. Whether the n will goes up or whether the n will comes down.
It will goes up.
It goes up.
It goes up.
See,
So
Yeah, in your sample or in your population, the variance is very high. You have to go in with a more number of samples. Suppose if the variance comes down, instead of a 10, it is only 5. If it is only 5, what happens? The n will come down. The n will come down. Okay, are you clear now? Are you clear?
Yes.
Yes, sir.
Right. One
Yes.
more hypothetical situation, let us take it. In the classroom, all the students has got 60 marks, 61 marks. All the students have got only 2 marks. Only 2 marks they have got it. All 100 students. Imagine 100 students are in the classroom. Everybody has secured 60 or 61. Okay. What about the average? What about the average? Roughly
60.5.
60.5, obviously. Right, okay.
Hmm.
How many samples is required to draw from the 100 students to make an inference about or to find out the average marks? You are drawing a sample. How many samples is required to predict the mean value of 60.5? How many samples is required? Apply your common sense. 100 students are there. Each student's gotten 60 or 61 marks. Your average is 60.5. Roughly, I am saying. How many sample is required to predict the mean value of the population?
50%.
50%. Why? Even a one sample is more than sufficient.
One.
Even one sample. If you are drawing one sample, the sample may be an 60 or the sample may be a 61. And if you are saying that it's equivalent to 60.1, 60.5, the 60 is closer to 60.5. So the one sample is more than sufficient to represent this population mean.
If we know about all.
Yeah, because everybody is 60, 61. One
But
sample is
provided
more than
we-
sufficient.
Provided we have the complete information initially only that everybody is getting that.
Yeah, hypothetically, imagine, hypothetically we are discussing about it. See, if it is a 60 and 61, what about the variance? Variance is too low. Variance is too low. Is it right, my dear friend? If the variance is too low, even a one sample is more than sufficient to represent the population. Is it right? Imagine the same 100
Hypothetically,
students.
yes.
Pardon?
Hypothetically, if we are taking this, then it's fine.
Yeah,
But otherwise,
for
in the
understanding
real
purpose.
situation and ideal situation,
No.
it will not.
In the ideal
Practically, it will
situation,
not
it is
be.
not. Ideal
It will
situation,
not
it
be.
is not at all possible. For understanding purpose, I am saying,
Yes,
if this is the case, even a one sample is more than sufficient
It's
to
fine.
represent the
Yes.
population. So the variance is too minimal here. Suppose in your class, the mark ranges from 0 to 100. The mark 0 to 100. How many sample is required to represent the population mean? How many
It's a mark.
samples? Roughly, can you say that it's a 30% of the sample? 30% of the population? Can you say 30 students marks is sufficient to represent the population? Roughly, can you say? If the marks is widely distributed, obviously the more number of samples is required to represent the population. Forget about 30, 40, whatever may be. Higher the sample is required to represent the population.
Right.
Right. Then
Variance
variance is high,
variance is-
more sample is required. If the
More
variance is less sample is required. Can you now
Right.
have a rule of thumb now?
Yes, sir.
That's all. See, please see, if the study of the populations have a wider distribution, you have to go in with a large sample to represent the population. If the population of the studies have a very minimal variance, even a small sample is sufficient to represent the population. Have you got it now? Yeah, that is all about this particular formula. If you are requiring a more accuracy, imagine the numerator is constant. More accuracy means what? With a more precision. More precision you would like to identify it. If the more precision, the d values are too minimal. The d values are too minimal. If the minimum value lies in the denominator, what happens to the n? If the d, say for example, I would like to predict the marks plus or minus 5 marks. Plus or minus 5 marks I would like to predict. But instead of a plus or minus 5 marks, I would like to predict a plus or minus 1 marks with which more accuracy with which I would like to predict. If it is a accuracy level instead of a plus or minus 5, if I'm taking plus or minus 1, the D value will be minimal. If the D value will be minimal in the denominator, what will happen to the N? N will goes up or N will come down?
Inverse.
N will,
It
N
will
will
go up, sir.
Inverse.
it will
Inverse
goes up.
series.
Yeah. If more accuracy you are demanding, more sample size is required. If you are expecting a less accuracy, the less sample size is more than. Can you now understand now?
So will you please repeat this last one?
The last
Where
one,
you started with D.
the D is an accuracy. You have to decide. Say you are measuring the marks of the university. Okay, you can predict accurately. You can't predict. Never you can't accurately predict. You can't predict with the plus or minus. Is it right?
Right.
You can try to predict the marks with the plus or minus 5 marks. This is a one accuracy level. Instead of a plus or minus 5, if you would like to increase your accuracy level, plus or minus 1 mark. Plus or minus 5 is a lesser accuracy. Plus or minus 1 is a more accuracy.
Right.
If it is a more accuracy, the D value will be minimal. If the value is a minimal, the numerator is a constant. Imagine what will happen to the N. If lesser and lesser of the D square value, what will happen to the N? N will come down or N will goes up? N will come down or N will goes up?
Increase.
Right. Yeah, 1 minute. The numerator value is 100. 1 minute. The denominator value is 10. What is the value? What is the value? 10 is a N value. 10 is a N. The 10 represents D square. The 100 represents sigma square and Z square. For example, let us take it. Sorry. Now you are increasing the accuracy level. So the numerator is a constant. You are increasing the accuracy level. Instead of a 10, you would like to make it as a 5. What will happen to the N now? What will happen to the N now? Increases. That's all. If more accuracy, more number of samples. If it is a less accuracy, less number of samples. Less number of accuracy, less number of samples. More number of accuracy, more samples. Less accuracy, less samples. Variance means higher the variance. If the variance is very high, more number of samples. If the variance is less number of samples.
Less number of
got
samples.
it now? Yeah, that's all. Please
Yes,
make
sir.
a note of it. See, this is a principle. Even there is no need to apply formula. See, common sense we have to apply. See, when the students are approaching us, madam, what is the size of the sample I am supposed to write? Yeah, what is the populations you are studying? Then again, in general, you are observing that the populations have a high variance. If it is a high variance, always you have to suggest the more number of samples. More number of samples. But what is the number of samples? You have to apply formula. You have to derive the exact number of samples. You have to apply the formula. Okay, are you clear now?
Yes.
Right. Now I am coming to the Z square. The Z square is also like a confidence level. What is the confidence level with which you are making inference about the population? Say, for example, I am saying that the confidence level is 95% confidence level. What do you mean by 95% confidence level? There's a 1.96 sigma. So the Z value is a 1.96. The Z value is a 1.96. If it is a confidence level is 95%. Okay. What is a 95%? See, if you are taking 100 samples, take it 100 samples, 100 times. Out of 100 samples, 95% of the time, what I have concluded will be concluded by the samples.
Correct.
5 times maybe a wrong conclusions may be derived. That is a confidence level, because I can't say that 100% the same results will occur even if I am taking some other sample. That is called as a confidence level. If the confidence levels goes up, what happens? The sample size will also the confidence levels comes down, then sample size will come down. Okay, now all of you are comfortable with the relationship of a Z square with N, confidence level with N, and accuracy level with N? Yeah, this is for proportion. This formula is for proportion. Pi represents proportions. I hope all of you can understand the symbols. P, small p represents sample proportion, pi represents population proportion. Okay, right. Now, I'm coming to the next one. Initial sample size. What is an initial sample size? The initial sample size is nothing but final sample size divided by incidental rate plus into completion rate. My sample, final sample, ultimately I would like to take 1,000 samples. 1,000 samples I would like to take for the analysis purpose. I'm going and I'm meeting the people. The respondent may not be. So when I am meeting 10 respondents, out of 10 respondents, I can meet only 8 respondents. What is an incidental rate? Out of 10, how many respondents you are meeting? 8 only. Then again, the incidental rate is 0.8. Multiplied by. Out of 8 people, only 2 people have not completed the questionnaire. Out of 8, 6 of them have completed the questionnaire, complete, thoroughly, without any bias. But 2 of them have not completed. Halfway through, then again they have refused. Out of 8, only 6 that it has been materialized. What is the completion rate? The completion rate is 75%. Out of 8, only 6 of them have turned up to complete. That is a completion rate is 0.75. So the 1,000 divided by 0.8 into 0.75 will give a initial sample size. This is a sample size. This is always greater than 1,000. That maybe say, for example, 1,400. Roughly, I'm saying. So when you are starting with 1,400 samples, because of the incidental rate and because of the completion rate, you may end up with finally 1,000 samples. Sir, how can I calculate the incidental rate, completion rate? By conducting a pilot study. By conducting a pilot study, you can conclude what is an incidental rate and completion rate. This is a scientific method of deriving the sample size. In your research paper or in a research work, obviously they will say how you have decided the sample size. That is a crux. Because subjectively you have decided the sample size that it may not really represent the population. Scientifically, if we have decided the sample size, that it will really represent the population. Concretely, we can say that my sample is a appropriate sample, that it will reflect the characteristics of the population. Confidently, we can say. All of you are comfortable with this process? So hereafter, whenever you are conducting a research work, please apply this formula and then again decide the sample size. And even in PhD works, the people are struggling. Okay, so always please apply these 2 things. If it is a proportion, go ahead with this formula, and this is the initial sample size formula. And if it is a numeric value, you have to go ahead with the first formula. And any doubt or any clarification, please tell me. Come on, guys. Come on. Yes? Shall we move to the next one? Now, time is 7:24. Another one slide we can cover, and thereafter, then again, we can make a break for 5 minutes, and afterwards, we can resume. Is it okay, my dear friends? Is it okay?
Yes, sir.
Right.
Sure, sir.
Right. Now, there is another approach. There is another approach. This is a Fisher's approach for deciding the sample size. There is a terminology called as a small effect, moderate effect, and a large effect. With the scenario, I will explain this effect size. Imagine I am in the process of finding out the headache medicine. Already, some of the medicines are there, Brufen, Saridone. There are some of the medicines are there, right? So I am inventing a new medicine, and I am administering that particular new medicines with you. And you are having a very headache, and then again I am suggesting why not you can take this new tablet, and then again please tell me your feedback. Then you are taking the medicine and you are taking a rest. Next day morning I am asking a question. What about that medicines? Whether the medicine is very effective? You are saying that, yeah, it's really effective. When I took it, then again within 15 minutes, then again the headache has gone. You can say like this, it's okay, but it's not like a Saridone, but it's not that effective. That is a small effect. Large effect means, yeah, superb. As soon as I took it, then again within 15 minutes, that headache has gone. Then another thing, you may say that it's okay. It's not that good. It's not that bad also. It's okay. It's equivalent to that existing medicines, you can say. That is called as a moderate effect. Whenever we are conducting a research work, and when we are proving that the null hypothesis is accepted, null hypothesis is accepted. So, for example, you are testing a health drink. Really, the health drink is increasing the energy. You are concluding it. Yes, you are saying that the energy drink is increasing the energy level. How far? What is the effect size? Whether it's a small effect, or whether it's a moderate effect, or whether it's a large effect. For that, the Fisher suggests the formulas to measure the effect size. If the effect size is, my dear friend, if the effect size is mentioned from 0 to 1. The effect size is mentioned by 0 to 1. If the effect size is 0 to 0.1, okay, 0 to 0.1, it's a small effect. It's a 0.1 to 0.3. Sorry. 1 minute. So if it is a 0.1 to 0.3, okay, 0.1 to 0.3, it's a small effect. 0.32 to 0.5, it's a moderate effect. This is a small effect, this is a moderate effect, and greater than 0.5, it's a large effect. The value ranges from 0 to 1. Is it right? 0 to 1. The value that ranges from 0 to 1, the effect size. All statistical tests, you can measure the effect size. Even this, especially in the science field, without effect size, you can't publish the papers. Always the reviewer will ask, what is an effect size you have calculated? Okay, but in social studies, normally we are not measuring the effect size, but the best approach is measuring the effect size. Okay, so for example, teaching pedagogy. You are administering a new teaching pedagogy, and you are concluding that the new teaching pedagogy is effective, right? How far? Whether it's carry a small effect or a moderate effect or a large effect, that you have to conclude by quantifying that particular effect, that it ranges from 0 to 1. 0.1 to 0.3 means small effect. 0.35 to 0.3 to 0.5 means a moderate effect. Greater than 0.5 means large effect. See, the Fisher's, what he says is, if it is a large effect, how many sample is sufficient? Tell me, how many sample is sufficient? How many sample is sufficient? If it is a large effect.
28, sir.
More than sufficient. There is no need to take more than 28 samples. If it is a moderate effect, how many sample is required?
85.
And if it is a small effect, how many sample is required?
783.
3 samples minimum required. Please understand. Sir, how can I measure the sample? Effect size? Pilot study. You have to conduct a pilot study, and you have to measure the effect size, and based on the effect size, you can decide the sample size. In the pilot study, you are concluding that the effect size is a small, you have to go ahead with this minimum of 738 samples. If it is a moderate effect, you have to go ahead with an 85 samples. If it is a large effect, you can simply choose only 28 samples. It's a small sample, more than sufficient. Okay, because larger the sample, more time, more cost, more energy is involved. This is a one approach. Which one is in one approach? The previous one, what I have shown, is a one approach. Okay, the previous one is a one approach. This is a one approach. Either this approach or the effect size approach. Either one of this you can apply, or both you can apply, and you can decide the sample size. Scientifically, if you have decided the sample size, everybody will recognize your research output. Otherwise, the output will be questionable. Now, I am stopping here. Now, tell me, are you having any doubt? Because I am not spending much time on sampling technique and all other things. So please study. That is a n number of books are there. And the sample size determination, always the people are struggling. That is the reason why I am spending much time. So in some area, I am spending much time. In some area, I am asking you to consider on your own. Depends on the necessity only. Don't take it in a negative sense. Okay? Right. My dear friends, it's okay. Any clarifications or any doubt is required? Any doubts is supposed to be clarified? Come on, guys. Clarity is there. So far, what we have covered: scales
Yes,
of
sir.
Yes,
measurement,
sir.
Yes, yes.
scales of
Yes, sir.
measurement, nominal, ordinal, interval ratio, and followed by sampling design. In the sampling design, defining the population, how to define the population, how to decide the sample size. Okay. And in the sample size, two approaches we have seen, and one more learning is a effect size. Effect size is nothing but if the alternate hypothesis accepted. If the null hypothesis accepted, there is no need to calculate the effect size. If the medicine is not at all working, why I am supposed to bother about the effect size? If the medicine is working, then again I have to measure the effect size, whether the working is a very effective one, or it's a moderately effective, or a so very least effective one. I have to measure it. Okay, right. Now the time is 7:32. Sharp by 7:37, we can start the session. I think 5 minutes is more than sufficient, or shall we make it as 7:40? Shall we make it as 7:37? Right, okay, make it as a 7:40. Okay, 7:40. In my watch, 7:32. Be here by 7:40. Please join the meeting with 7:40. Meantime, I am online only. Those who would like to clarify the doubts can clarify the doubts. Is it okay, my dear friends?
Yes, sir.
Yes, sir.
If you are silent, then again, both the way I can take. Either nothing has not been go inside the our thought process. I can take it in that way, or otherwise everything is clear. That way I can take it. In which side then again I am supposed to take?
It's either
Either the
all
first one
clear
or
or
second one.
no.
Either first one or second one I am supposed to take. Right, okay. Guys, take a break, and those who would like to clarify the doubts alone can stay back and ask the questions, or otherwise I will also go for a break. Okay?
Sure, sir.
Right, okay. Thank you. Right. So today time may not permit me to take you to that particular statistical error, type 1 error, type 2 error. And please keep it in your mind, repeated measure have a minimal statistical error than the independent measure in general. Okay. But the choice of a repeated measure or an independent measure is purely our necessity. Purely our necessity. So for example, another example I can quote. I would like to using a two type of a seed. I'm preparing a land in that I am applying the seed. First type of a seed, and I am measuring the cultivation level. After harvesting it, I'm preparing the same land, but I am applying the second type of a seed and I am measuring it. It is a kind of a repeated measure. The same land I am using it. That is the reason why it is a repeated measure. Suppose if I am having a two different locations or two different land, if I am preparing it, I am applying in one land type 1 seed, in another land type 2 seed, if I am applying it, this is called as an independent measure. Okay, are you clear now? Clear or not clear?
Yes, sir.
Right, okay.
Yes, sir.
Others also? Because if you are miserably failing to understand this one, you can't decide whether it's a paired sample t-test or an independent sample t-test. Like then again, you can't ANOVA, one-way ANOVA, or repeated measure ANOVA or a independent measure ANOVA. You can't decide it. Please ask me if you couldn't understand. Once again, I will repeat it because it's a very crux. This concept is very crux.
Sir, I have a question.
Yeah, please, madam.
Sir, in case of if our study
Hello, madam, voice is breaking. Hello.
requires the understanding of the attitudes of people. Yes, sir.
Yeah.
If we are studying the attitude of somebody, or if we are studying the preferences of some customers,
Okay,
that
madam.
may vary.
Okay, madam. Hello.
Hello. Yes, sir.
Madam, voice is breaking. Please, once again, madam, repeat.
So my question is, if we are studying the attitudes of customers or the preferences of customers towards certain product, then will the independent measure be a better type of measurement, or will the repeated measure work for us here?
Madam, both we can apply here. Say, for example, context 1, context 2. Let us take the same set of customers has been exposed for the preference of a product in a different context. Same set of customers. Then that will fall under the repeated measure. You are having a one set of customers to one context, and another set of customers in another context, in which how they are preferring the products, or how they are choosing, or how they are behaving, or what is their attitude, and all of the things. That is an independent measure. Okay, madam? And
sir.
Now both are possible. But which one I am supposed to choose it? Purely it depends on your necessity. Suppose if you would like to reduce your statistical error, always it is a better go ahead with the repeated measure. Both the measures, repeated measures and independent measures, have a pros and cons. Okay, but preferably we can go ahead with the repeated measures than the independent measures. Suppose in case if you are thinking that the independent measures is an appropriate for that given requirement, then again you can prefer the independent measure. Nothing wrong. Purely it is a choice of the researcher. Depends on the necessity.
Okay, sir. Okay, sir. Thank you.
Thank you. Right. Anything else?
So I just want to add, I mean, I don't want to question, I don't have any doubts here, but I just want to add, like you have mentioned here that repeated measure helps us in reducing the error. That is one thing, that is correct. But sometimes there are certain drawbacks as well. Like if you repeat that test very frequently.
Yeah,
if,
that is the reason why I mentioned that always it's a pros and cons for
there are pros and cons, and especially when we are testing maybe child psychology, or maybe especially when we are taking inductions in case of jobs. In that case, sometimes people memorize.
Yes, ma'am.
And then it would lead to
if that is the case, you have to go with an independent measure. That is
yes, sir. That depends on our objective. Right.
But in general,
In general,
you
it
can
is.
say,
It's in
yeah,
general.
yeah,
Yeah.
yeah.
Yes, sir.
So good, madam. It's a very nice interactions. Come on, please. I'm
Thank you.
encouraging all other participants also come forward to discuss about it. Come on, guys. Come on. Let us move now further. Right.
Yes,
Now
sir.
I'm taking you to the next slide. Okay. Parametric versus non-parametric data. Madam, somebody has asked about it. Okay, what is in pre-assumptions and all of the things. Okay.
Yes,
Now
sir.
I'm
It was
taking
mine.
you to the particular. Yeah. Now it's so this is the conditions for applying for a parametric statistical data, statistical test. Normally, we are called it as a parametric data, non-parametric data. When a data can be called as a parametric data means if the four conditions has been fulfilled by a data set, then that data set is called as a parametric data. And if you are having a parametric data, you have to apply parametric test. Suppose any one of that particular conditions has not been fulfilled by your data set, then it is called as a non-parametric data set. At the time, you have to apply non-parametric statistical test. Okay, right. What are all the conditions? What are all the assumptions or what are all the prerequisites for the parametric data? A sample data, what you have collected, supposed to be normally distributed. And your data, at least interval, preferably it is a ratio data. At least interval, preferably ratio data. And the variance of the data set supposed to be homogeneity. And the independence test, meaning here is the selection of the data set have an equal chances of getting selected. Okay, so the at least interval data, the equal chance of getting selected, or the random selection. I can say that random selection here. The bottom two are by that is lying in our hand, but the top two are not lying in our hand. As a researcher, I can decide, yes, I will prepare or I will collect the interval data. I will ensure that it's an unbiased data collection. So I will ensure that if by ensuring that, then again I can fulfill this bottom two conditions, but the top two conditions I have to apply test. For a normality test, I have to apply Kolmogorov-Smirnov test or Wilks-Short test. I'm not going into teach you how to conduct the test and all of the things. So just here learning the concepts alone because of the time constraints. And the homogeneity of variance, I have to go ahead with the test. Okay. Then again, what do you mean by homogeneity of variance? Then again, that also, then again, I'm trying to explain it in the next slide. For a normality test, Kolmogorov-Smirnov test or Short-Wilks test. For a homogeneity of variance, Leibniz test. That is a test name is a Leibniz test. What do you mean by homogeneity? Normality, it's okay. I'm seeing the normally distributed data, normal curve, I am aware about it. So if it's a skewed data, I can't I can't say that it's a parametric data. If it's a positively skewed data or a negatively skewed data, it's okay. I can visualize it. What do you mean by homogeneity of variance? With a small example, I'm trying to explain it. Here, there are two graphical presentations. One is in the left side, another one is in the right side. And in the x-axis, I am taking a different kind of concepts at different locations. And here, this is ours. Bother about that data set. Take it to only the line chart. See here, the dots are all individual data points, and the red color icon is a mean value. Okay, right. So from the dots, if the dots are scattered widely, the variance is very high. If the dots are too closer, then the variance is less. See, comparatively speaking, left-hand side graph, right-hand side graph, in which graph the data sets are widely dispersed or widely distributed? Come on, tell me.
Hand side, sir.
Right side. Right side, the first data set. Let us take this data set. And whether the variance is very high or very low.
Very
Roughly,
low.
it's very low. And what about this variance? Here, tell me.
It's very
You are
high.
comparing this data set with the data sets. Imagine you are comparing these two data sets. The data set one have a variance of this size. The another data set have a variance of this size. Which one is have a very high variance? Which one is have a very low variance?
New
The
Newcastle
Newcastle has high
Newcastle is
variance.
high.
high, and then again Brixton Academy is a very low variance. In this case, there is no homogeneity of variance. See here, this is a one data set and this is another data set. Tell me whether both are homogeneity is there. It's not exactly similar.
Relatively, relatively more.
But
Relatively
it
it's
is
similar.
relatively there.
Yeah.
Yes, sir.
This is all about homogeneity of
Homogeneity.
variance. That's all. Whenever you are talking about a two data set, the data set one variance and the data set two variance are supposed to be more or less similar.
Similar.
If it is not similar, that particular data set is called as a non-parametric data set. Okay. So what are all the tests are there? Now, come on. Here, this one is what? Normally distributed. If the data set is, if it's lies like, if it's distributed like this, it's normally distributed. Suppose it's look like this, it is not normally distributed. Homogeneity of variance. Now I think I hope all of you have visualized it. It is an interval data, at least interval data, preferably ratio data. It is an independence of selection of each sample, meaning here random sample, completely random sample, or otherwise I can say that unbiased selection of elements. Each and every elements in the population should have an equal chance of get selected. Is called as independence. Okay, each and every elements in the data point in the population should have a equal chances of getting selected. It's a completely random selection, unbiased selection, I can call it. So these two things are in the hands of the researcher. I can decide, but these two things are all based on the test. What is the test I am supposed to apply? I am supposed to apply Kolmogorov-Smirnov test. What is a Kolmogorov-Smirnov test I have to apply? For testing the normality. If it is normally distributed, what can I say? The data set is parametric data. Suppose if it is normally distributed, then again I can call it as a non-parametric data set. Similarly, homogeneity of variance. Leibniz test I have to check. If it's a homogeneity of variance is there, then I can conclude that the data set is a parametric data. Otherwise, it is a non-parametric data. Right. So, in the real time, achieving the normally distributed data is a too difficult task. What shall I do? Yes, you can relax this test. You can relax this rule. Even it is not normally distributed, what is the test you have to complete it? Compulsorily, you have to check the homogeneity of variance. The homogeneity of variance, simply you have to avoid the parametric test. Even if it is not normally distributed, you can go ahead with the data conversion. Inverse data, logarithmic data conversion, natural logarithmic conversion, then again inverse conversion, then again squaring the values. By converting the data, we may try to convert the data set into a normally distributed data sets. Okay, but what is a very important test? The very important test is a homogeneity of variance. Right. I'm stopping my lecture here, and I'm waiting for the questions from your end. All of you are comfortable with the conditions? What are the 4 conditions?
Yes.
Normally distributed data, homogeneity of variance, at least interval data, preferably ratio data, and random, completely random selection. Each and every elements in the population should have an equal chance to get selected. Okay, that is a thing. And all the 4 conditions has been fulfilled. Parametric. At least 3. Sacrificing the normally distributed data, we may call it as a parametric data. In the social study, in the science, stringently we have to follow the 4 conditions. If it is not fulfilled, we may call it as a parametric data. If it is a parametric data, what is the test you can apply? Parametric test. If it is a non-parametric data, what you can apply? Non-parametric test. Each and every test in the statistics are having an equivalent non-parametric test. So, for example, repeated measure ANOVA. What is an equivalent test means? I can say that Friedman one-way repeated measure ANOVA. It's an equivalent test. Okay, equivalent test. I can say. Okay, right. I'm stopping my lecture here. Please clarify your doubts now. It's a time to clarify the doubts. Yes, my voice is audible.
Yes, sir.
Right. Any doubts or any clarifications? It's okay now. Shall we move further?
Yes, sir.
Right. Types of variables.
Yes, sir.
I thought of it. Is it necessary to cover the types of variables? I
Yes,
hope
sir.
you can learn on your own. So I'm skipping that one. I'm coming to the statistical. It's a very important. And normally you will struggle. And this kind of inputs you couldn't get it from the net by in general, I can say. Okay, right. Now, whenever I am trying to build a model, statistical model, right, before that, I'm asking a question. You are conducting a test for your classroom or you are producing something. How can you represent your class performance? How can you represent your class performance? You are conducting an exams. Students are writing the exams. You are evaluating the papers and you are distributing the marks. And your principal or your head of the department is asking about the class performance. How you will represent the class performance? How will you represent your class performance? Come on. Whatever that it strikes in your mind, please share. Don't bother. Never you should hesitate. What that is strikes in your mind. Sharing that one. Come on, madam. Come on.
So we can use different presentation skills like tabular methods and presentation charts.
Right, okay, the marks are there, but how the overall performance? What is the in one single word? Then again, your head of the department is asking to say about your class performance.
Normal
How can you say?
distribution.
Normal distribution. Yeah,
Curve.
right, okay.
Normal curve.
One normal curve. Then again, other than that, can you apply anything else? What is the regular measures we are using it to represent the class performance?
Percentage or
Yeah, percentage. The
simple
first
would
one
be
always.
percentage. Huh?
Yeah, always we are using the percentage. Sir, my class average is 80%.
Yes, sir.
So that is the representation of the class performance. Normally we are, yes sir, rightly you have pointed out that normal, that is the mark distribution, sir. How the mark that it has been distributed. Yesterday we have seen it. Is it right? It is a positively skewed or it is a negatively skewed or it is a normally distributed. Like I can characterize the students' performance in the examinations, right? Okay. But in general, in a single word, when I am trying to describe the students' performance, percentage. It's very good. This is a basic thing. Then again, here also we are taking it. See here, let us take these are all the marks and how we are representing the students. We are representing the students in the average. This is an average line. This is an average line. So the average marks, say for example, we are conducting an exam for 20 marks and the class average is 10. But when you are trying to predict the marks of the student, then this is your average. But the actual mark of the first student is how much? 3. From 3, how far this your representative marks is there? 10. And what is the deviation? Minus 7.
Minus 7.
This candidate, the 7th candidate has secured 17 marks, but your class average, what you are representing is a 10. It's a plus 7. Yeah, that is a deviation from your class representation. Is it right, my dear friend? But this is normally a basic model. Always in the statistics, this is a basic model. Can I improve this basic model? Yes, possibilities are there. I'm going with the improved model. See here, this is an improved model. This side, this is an improved model. Okay, I can take up the color. Okay, I can take up the color. 1 minute. I can take up the color. Oh, sorry, error. Yeah, here I can take up the color. Yeah, this is an improved model. So this is an improved model, and see here the 7th candidate. Let's just take the 7th candidate. In the basic model, what is the deviations? from the basic model, from the basic representation of the mark, how
Yes,
much
sir.
the marks that it has been deviated as far as the seventh candidate is concerned?
7.
0.7. When I'm improving the model, see here, your error has been come down. This is an error. Actually, this is called as a prediction error. This is called as an error term. Normally, we are using the error term. In the regression model, we are mentioning it as an error term, and this is an error. Okay. In the production, this is an error. And when I'm improving the model, your error term has come down or that it has been increased,
Yes, it reduced.
reduced. Coming to the first candidate, what happens? What happens here? What happens? Reduced. Error term has been reduced. Error term has been drastically reduced. Is
Reduced.
that? Yeah, reduced. So this is an improved model. Okay, this is an improved model. Right. Now I'm taking both the models here in this bottom page. In this bottom page, I'm taking both the models and see from this basic model, and this is an improved model. The sloping line is an improved model. The horizontal line is a basic model. The difference from the basic model to improved model is called as a explained variance. And even if the model has been improved, some of the portions has not been predicted. That is an unexplained error. Now you may heard about it, the explained variance, unexplained variance, R squared. Have you heard about that particular word R squared in the regression analysis or in the ANOVA?
Yes, sir.
The R square, coefficient of determination. Normally we will call it as a coefficient of determination. How much percentage the model explains? 80% the model explains, meaning the remaining 20% the model is not explaining. Normally we are saying this is in general. I am not talking about regression. I am not talking about a correlation. Anything else, whatever may be the statistical model, this is a basic principle with which we are working everywhere. Even in the factor, cluster, conjoint, okay, or it's a regression model, logistic regression model, or a correlation, simple correlation, or multiple correlation, or a correlation, whatever may be, we are talking about explained variance, unexplained variance. This is the meaning of explained variance and unexplained variance. Okay, now I'm taking you further. This is from the basic model, how the individual observations are deviating. That is a total variance, SST. And from the improved model, how the individual observations are variating. That is an SSR. And the difference between the basic model and the improved model, SSM. Normally, I hope you can understand that the SSR, okay, divided by SST. Normally, we are dividing it in the ANOVA. This is called as an F ratio. This is called as an F ratio. Or wherever you are seeing SSR divided by SST, SSM divided by SST. This is called as R square. This is called as an R square. I am trying to make you to visualize the outputs. Okay. I am not trying to explain how to calculate and all of the things. I am trying to make you to visualize what do you mean by explained variance, what do you mean by unexplained variance, what do you mean by SST, SSR, SSM. Wherever the model is there, statistical models are there, whether it is a univariate model or a bivariate model or a multivariate model, this is the basic concepts you have to understand. Right. I'm stopping my lecture here and then again I'm waiting for your response. If you are having any doubts, you can ask. And this particular explanations you can get it from the book called as Andy Field, Discovering Statistics Using SPSS by Andy Field. Foreign author book. From that you can get a lot of insights. Wonderful book. From that only then again I am adapted this particular concept. Okay. Very beautiful book.
So is the soft copy available?
Madam, why not you can buy?
No, I'm just asking.
Yeah, the Kindle.
Because it's a foreign author, you're saying.
Yeah. No.
Definitely would be expensive.
In the Kindle. Even it is explaining, it's worthwhile to buy. Please buy the book, keep it as a Bible, as a Quran, as a Bhagavad Gita. You can keep it with you if you are much inclined towards statistics.
Yes, sir. Sure.
Okay, that is available in Amazon.
Okay.
And also the old version PDF is available, freely available. Old version.
Okay.
The old version PDF is available freely. You can download and you can use it. Suppose if you would like to use the latest copy, then again you can buy. There are two things are available. Discovering statistics using SPSS by Andy Field. Discovering statistics using R, programming. That is also available by Andy Field. The author is explaining the statistical concepts without any formula. If you would like to conceptually thorough, you can use that particular book, but extensively you can read, patiently you can read from top to bottom. Not like then again the surface reading is not at all. If you are a surface reader, don't buy the book. Don't buy the book. Really, if you would like to learn, Andy Field, he is from England. Andy Field, discovering statistics using SPSS, discovering statistics using R. Old versions are available, freely available. The PDF you can download it, or otherwise go to the Amazon, use the Kindle, and even the Kindle book you can buy, or even you can order the hard copy. Even if it's a 2,000, 3,000, it's a worthwhile to buy. I'm highly recommending. Even a 2 copy you are buying it, 1 copy for a home, 1 copy for a office, it's worthwhile. I'm recommending, strongly recommending. 1,000 times I'm recommending.
No, I can see the presentation.
I enjoyed the book like anything. See, he is bringing the characters like a cinema. He's bringing the characters, and each and every character will something. Then again, some of the characters are the people, those who would like to dive in deep in the concepts. That character will appear wherever that strong concepts are appearing. Some of the people are the surface readers. They are trying to prepare and concepts for the examination purpose. Such a kind of a character will appear in this that particular junction. Beautifully. Then again, he brought the characters, and then again he's explaining. I enjoy like the book like anything. Past 20 years, I'm reading the books multiple times. I'm reading them.
So it is visible in the presentation as well.
Beautiful book. As a teacher, then again, always I'm trying to share. Then again, those days I couldn't get that particular copy of the book. I xeroxed it, and then again I kept it with me. And as soon as that is available, foreign book available, version available, I ordered it, and then again I organized nearly 30 to 40 books I ordered, and I have distributed among my colleagues.
Very nice.
And because we have to respect the author, when we have to pay something for that author. Very nice book. Right, okay. Now, we are deviating. Sorry. Then again, now, this is the one. Then again, I'm explained the variance, unexplained variance. Y minus y dash, and y dash minus y bar, and the total variance is y minus y bar. Y minus y bar is a total variance. This is called as SST, and this is called as SSM, and this is within variance, or this is a between variance, this is within variance, and this is total variance. Okay, and this is called as SSR. SSR means this in ANOVA parlance, we can say that this is within variance, this is between variance, this is total variance. This is called as a between, this is called as within, and this is called as a total variance. In ANOVA, they are using the word between variance, within variance, total variance. You can visualize this one, because whatever the calculations, we have to visualize it. What is it all about, the calculation? Simply adding something, dividing something, that does not give a insight. Once if you are getting an insight, adding, subtracting, deletions, multiplication, divisions, the system will take care of it. That part, then again, leave it to the software. But try to understand the conceptualizing the concepts, visualizing the concepts. That is very, 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 very okay. I hope Everybody has now got it, the meaning of the between variance, within variance, total variance. The people already, those who are not having an experience about the ANOVA, don't bother about it. Keep that particular words, even the download the video and keep it with you. Whenever it's required, replay it and then again go back and then again start to associate with an ANOVA. When you are learning, you will get a complete insight about the ANOVA. Okay. ANOVA is nothing but it's an old school of thought. Regression is a new school of thought. ANOVA is a classical school of thought. Regression is a new school of thought. Both are same. Never ever anybody can't taught that one, but Andy has taught that regression is a new school of thought. ANOVA is a old school of thought. The ANOVA can be solved by introducing the dummy variable as a regression. He proved it and he have showcased it. Unless otherwise we are understanding that the ANOVA can be solved with the dummy variable as a regression, you can't understand the multivariate analysis. You can't understand the multivariate analysis completely. Okay, right. With that, then again, what is the time? Sorry, 18. So the last 7 minutes, I am using the next one. I am coming to the last one. I am skipping that one, hypothesis and all of the things, sorry. And now I am into the parametric test. What are all the parametric tests? Parametric test, correlation. Can you say that what is the correlation? When two variables association, when you would like to measure, you have to apply correlation. That to ratio data. That to ratio data. Ratio data, two variables. Sir, if it is a ordinal data, what shall I do? Rank correlation. Ordinal data, rank correlation. Sir, it is a nominal. Correlation cannot be conducted, but association test can be conducted. Association test can be conducted. Sir, what are all the association tests can be conducted? In the non-parametric test, I will showcase to you. Regression, all of you may aware about it. T-test, paired sample T-test, independent sample T-test. This is paired sample means I can say that first MBA students, first sem mark, second sem mark. First sem, second sem mark. It's an example. First sem, second sem. Same set of student. First sem, second sem. What is an independent measure? First year student performance vis-a-vis second year students performance of the odd semester. Okay, first year students is different, second year students is different. This is an independent measure. Right. Here you are comparing the first sem, second sem. In the paired sample, suppose if you would like to compare, okay, if you would like to compare first sem, second sem, third sem, there are 3 levels if you would like to compare. If it is a 2 levels, you can go to the paired sample t-test. If it is a 3 levels, you have to go to ANOVA. 2 and more, sorry, above 2, 3 and above. Even it is a 4, 5, 6, 7, whatever it may be the number, it is more than 2, ANOVA. Levels, I'm now saying it's a levels. Levels, it's a 2 levels, it is a t-test. If it is a more than 2 levels, ANOVA. Say example is first sem, second sem of the first MBA, if you would like to measure, paired sample t-test. If it is a first sem, second sem, third sem, fourth sem, all the 4 sem, if you would like to compare, you have to repeat and measure ANOVA. Independent measure ANOVA, I can say that first year BE, second year BE, third year BE, fourth year BE. Different group of people. First year BE is different from the second year BE. Different batch of the people. When you would like to compare independent measures. Okay, right. Now here, this is a one-way ANOVA. This is a one-way ANOVA because here you are talking about semester marks alone. Here you are talking about a semester marks alone, one way. But when you are talking about 2 factors, not only semester marks, you are keen on semester marks as well as the students' IQ level. Students' IQ level. If 2 factors you are comparing, semester marks performance, IQ marks performance, IQ levels, or even the math score. or even the higher examinations, or even the placement aptitude test score, whatever may be. The two factors when you would like to think, two-way ANOVA, the same thing applicable, independent repeated measures. The chi-square analysis also falls under the parametric as well as a non-parametric. Both the things the chi-square will fall. This chi-square is measuring the distribution. Whether the distribution is a normal distribution, not normal distribution, whether the distribution is a binomial distribution, whether the distribution is a Poisson distribution. Like to testing, chi-square analysis is appropriate. Now I'm moving to the next one. It's a non-parametric test. The non-parametric test, I can say now here, sign test is a one sample t-test. This is equivalent to one sample t-test. This is equivalent to one sample t-test. Mann-Whitney Wilcoxon rank sign is a t-test independent measure. Wilcoxon rank sign test, t-test, paired sample. Ruskell-Wallis one-way ANOVA, independent measure. Freudman one-way ANOVA, repeated measure. And Spearman-Rowe correlation, it's a correlation. Already I stated that it's a nominal data. Kendall's W B test. Kendall's W is this test and this test. Kendall's W is it's a distribution test. Kendall's B and C, this talks about the association test. This is a correlation test, a correlation for a nominal data. Normally we are called it as an association test. Is equivalent to correlation. Normally we are not saying it as a correlation. It is an association test for a nominal data. That too ordinal. This is for ordinal data. Association test for ordinal data. McNemar test is for nominal data. Coherence Q is for nominal data with more than two levels. My dear friends, I am not justifying with the proper explanations, little bit with the hurry. I have done it everything, but I have listed out the set of parametric test and non-parametric test. And what I will do is the equivalent test with this one. I will send the document to you. I will share it with the data star. Data star will share it to you so that you can take it as a ready recorder. Sorry, at the back end, then again, that too in the Sunday. I'm not supposed to extend the time limit. So I'm stopping here and I'm making the last 5 minutes for question and answer session. Okay. And here I have to skip the presentation. Now I'm coming back here. Now it's a time to interaction sessions. Any doubts or any clarifications you can ask. Precisely, I will repeat today what we have learned. Scales of measurement, nominal data, ordinal data, interval data, ratio data. And what is applicable, what is not applicable, that also we have explored. And followed by sampling design. In that sample size determination extensively we have seen the new learnings is a effect size, small effect, medium effect, large effect. Followed by another concept what we have learned is a types of measurement. Don't confuse with the scales of measurement and types of measurement. Types of measurement says that repeated measure, independent measure. Right? What do you mean by repeated measure? What do you mean by independent measure? Okay, and followed by what we have started is a basic statistical model. What is a basic model? What is an improved model? What is a SSR? What is an SSM? What is an SST? And what is an unexplained error? What is an explained error? What is a coefficient of determination? That is an R square. All these things we have learned. And followed by, we have learned about parametric data, non-parametric data. basic conditions required for determining whether the data is a parametric data or a non-parametric data. And followed by, we have learned about a set of parametric test and a non-parametric test. Okay. And tomorrow I will sit and then again I will prepare a document that it will, if the data is not normally distributed, how we proceed for the data. Madam or sir, I hope who is asking this question, Subbalakshmi madam is asking this question. Madam, first step we may try to go in with the data conversion, the data transformation. Actually, we may call it as a data transformation, reciprocal transformation or logarithmic transformations, or any kind of a transformations we may try. Most of the time, the transformations will help us to attain the normality. Even if it is not possible to attain the normality, in the social study, as an assumptions, we can ignore, and if the homogeneity of variance is there, we can go ahead with the parametric test. Suppose if you are keen on the assumptions and if you'd like to strict with this assumptions, you can go ahead with an equivalent non-parametric test. Equivalent non-parametric test is an assumption-free test. Assumption-free test. There is no need to the data what you have collected necessarily be normally distributed. Madam, I hope your questions has been answered properly. Could you get the clarity? Could you get the clarity? Okay, thank you, madam. Thank you very much. And one more thing in this particular juncture, I would like to share that in the Andy field, the author has stated that when he had started the PhD work, the first assignment what that it has been given by his teacher is taking the research thesis books and what is the blender they have done it. That is the work that it has been assigned for Andy. And he stated that so many research work, the blunder mistake that it has been done, like higher the roll number, higher the marks, or higher the roll number, lower the marks, like such a correlation studies that it has been carried out in the research work. So, yeah, even without knowingly, because whenever there is a numeric value, then again we are giving it as an input in the SPSS or any statistical software, and then we are taking it as an output and we are analyzing it. Garbage in, garbage out. That's all. We are analyzing it and we are interpreting also. Like I am saying that the roll number 1 plus roll number 2 equal to roll number 3. How I am concluding it? Sir, because I can add it here. 1 plus 2 is equal to 3. What is the wrong in it? I can say ignorantly, but there is no meaning of it. So, so whenever we are applying the test, please, we have to be very careful whether it's an appropriate or not. Thank you, guys. Any doubts or any clarification?
No, sir.
Yeah.
No, sir.
With the data sir's permission, sir, shall we invite the participants to give their feedback?
Yes, sir. Yes, sir. Please.
Yeah. Few people can come forward how we can improve this program rather than saying plus. If we are saying minus, probably data sir also myself also will take a note of it, and then again in future we will improve the program.
So I would take this opportunity to thank especially the organizing committee, Datta sir, and especially the resource person. The presentation was very clear in words as well as in the picturization. And all the doubts and clarifications have been clarified properly. And the only thing that I wanted more was the non-parametric test. I wanted to understand them in detail. So in case अगर आप आगे कभी भी कोई भी non-parametric test पे अगर specially करते हैं तो I would like to join again.
Yeah, but the necessity or
yeah, the time management and the punctuality.
Mobilizing the crowd for the non-parametric test, I think whether it's
yeah, I don't know about the rest of them, but like I wanted to know about the non-parametric test specifically.
Test.
Yeah, because the parametric tests.
Data sir, if the people are very interested to solve the problems, Then
Yes,
again,
sir.
what shall we do is we can take up the specific test and we can confine to the test, and then again we can go dive in deep, and then again we can teach them, sir.
Definitely,
That
sir.
if the size of the group of the people are there, we can organize.
Yes.
Right.
Yeah,
Let us explore, madam, and that
Yes,
one
sir.
then again we will take it into consideration. We will explore it, and if the
And
possibilities
yes.
are there, we will do. Surely we will
Surely,
do.
sir.
Right.
Sir.
Right. Okay. At least one or two from
Sir,
male
good evening,
side.
sir. Rajan from Skyline University, Nigeria.
Yeah, please, sir. Please proceed, sir.
Sir, Murugapan, sir, good evening.
Good evening,
Very
sir.
good
Good evening.
sir. But we need some workshop on that data analysis part. Okay. So kindly organize.
Hands-on working.
Yes, sir. Yes, sir. The parametric and non-parametric with the data, we have to work on it in the
With the
SPSS.
data, work on it.
Yes, sir.
Right.
So
Okay, sir.
give some
Let us explore, sir. Let us explore. Right.
Data, sir, thank you for this wonderful occasion and also giving this data analysis part also.
Thank you,
We are
sir.
expecting. Thank you, sir.
Thank you, sir. Sundarajan sir is from Nigeria, Sunstone University, and he joins in all our programs, and his friends also from there.
With pleasure.
Nice to hear, sir. Nice to hear. And Harshada Mystery, madam, or sorry, I couldn't bifurcate or identify it as a male or a female. Madam, your
it's a
question is a
female.
T-test. Yeah, female. Madam, it's a T-test and Z-test. If manually we are doing it, we are classifying it as a T-test, Z-test. T-test for a small sample size, that is a less than 30. Z-test for greater than 30, provided manually you are working and manually you are referring the table to accept the null hypothesis or reject the null hypothesis. In case if it is a software, the software straight away calculate the probability that it throws. So there is no necessity to classify it as a T-test, Z-test. If you are seeing it always in the software, you can see it only T-test, because the system calculates the probability straight away. But manually, when you are calculating the probability is a too difficult task by applying integral calculations, so that we are classifying it as a T-test, Z-test, provided it is a manual. It is a software, only one, that is a T-test. That's all. Madam, your question has been clarified?
So, sir, only when the population is unknown and the sample size is larger than 30, we can apply t-test. And other...
Madam, not larger than. If it is a small sample. See, one more classification is also there. I have not touched upon. The population is known, unknown, and all the things. Forget about that one. Take it alone, the sample size. If it is less than 30, apply t-test. If it is greater than 30, apply z-test. Provided if manually you are working the problem. Suppose if you are using software, in the software there is no such a kind of a classification as a t-test, z-test, and only t-test. Why? Because the software can calculate the probability straight away.
Okay, sir.
Right.
It's a very interesting question that comes from the students, especially on this one. Usually I have faced that question, that when it is exactly 30, what to do?
Madam, exactly. It depends again. See,
yes.
Try with the 30. Say, for example, if it is a 30, try with the t-test and z-test. The results are more or less similar.
Yeah. I know. I haven't. This is something that comes to me when I am teaching. So this is the question that comes. That comes in mind of the students. So this is a very interesting question, though, because in all of the books there is nothing clarified about that. What will happen when it is exactly 30? They are always saying less than 30 and more than 30. And so this. Sorry?
Less than or equal to 30, ma'am.
Less than or equal to 30.
Less than or equal to 30.
Yeah, correct.
Is it mentioned somewhere?
Yeah.
Different places are saying.
Okay. Can you give me any source?
I'll check and then try to...
Please.
Madam, please refer Malhotra. Marketing research by Malhotra.
Okay,
and
because
in the handy field also you can see.
Okay, I'll check in this one, because when we do statistics in social sciences, usually we do not refer the management books. So isliye maine pucha.
Right. Okay. Marketing research by Malhotra is another book.
I'll check that.
The author is an Indian origin, but then again is a professor in America. It's a very fantastic book, because it's a marketing is a common sense. That book also you can refer.
Okay,
Look also you
I'll
can
just
refer.
check.
You will get
Because
a
I've
lot
seen
of
for the
you will get a
chi-square,
lot
I've
of insight.
seen, because for the chi-square, I've seen that greater than or equal to 50. But for t-tests and z-test, I have never seen less than 1.
Less than or equal to 30 is a one, madam. Greater than
Okay,
30, less
I'll
than or
just,
equal to 30. Yeah.
I'll check that.
But nowadays, because of the software, the sample size
Yeah,
does not
software.
matter.
Yes,
Yeah.
yes, yes. Yeah. In the case of
Does
softwares,
not
we know,
matter.
but we basically go with the conventional teaching first. So
Right. Okay.
yeah.
Subbalakshmi, madam, you are also interested in a non-parametric test. Then again, we can go ahead with the examples, madam. In other
Yes.
occasions, then again, we will explore it and appropriately we will concentrate only on test. I will give the
Yes, sir.
scenarios, and then again with the scenarios, I will give the backup data. Even we can take the Excel as a common platform, because everybody is having the Excel, so that we can solve all the problems in Excel itself. Okay,
Yes,
we may
sir.
try with another workshop. Okay.
Sure, sir.
Right, thank you, thank you. Datta sir, already we had a more time.
Yes, sir. Yes, sir.
We continue. Anyhow, it's better. And
No
shall
problem.
we wind up the session?
Yeah.
Any doubts or any clarifications there? Or even feel free to communicate with me. Any doubts with your research work, please interact with me. I will support you. Don't worry. Don't bother about it. It's not one winding up the sessions. Yes, we are winding up the sessions, but in a long run, then again, for any work, for your own students or for your own work at your work, even if it's an organization or even it's a production line or any line, if you are stucking with, then again, please interact with me. I will also work along with you, so that I will in turn learn so many things from your end also. So I'm encouraging all of you to interact with me. Some other applications, some other contexts, then again let us meet and then again let us learn mutually. Thank you, thank you, thank you for your patience.
Thank you so much, sir. So we have come to the end of the 2 days workshop on research methodology, and it was very interesting sessions, both the sessions, and lot of interaction. And this shows the level of engagement as suggested by Sundarajan sir and Ramanpreet ma'am, Subbalakshmi ma'am, and Satyprakash sir. So definitely we'll plan for another workshop, okay, to do hands-on in details, and I'll discuss with Murugappan sir to take it forward. And one more important information, because I'm getting some WhatsApp message as well, that e-certificates will be mailed to all of you latest by Friday. I'm giving a little bit more time, but definitely I'll try to do it by in next 2 days itself, but be on the safer side. So I'm giving the deadline as on Friday, the coming Friday. Thank you once again on behalf of MTC Global family. I extend my heartfelt thanks to all the esteemed participants. And I'll request also, as Sir said, that all of you can be in touch with Sir. If anybody does not have his number or email, please connect with me in the WhatsApp. Definitely I'll share Sir's number so that you can be in touch. Thank you once again, and keep in
Datta,
touch.
sir,
Yes.
Just sorry to interrupt you.
Sir, please.
It was a nice session on behalf of all of them. Only thing is, Murugappan sir has given us an unlimited meals within 2 days, which we are all not able to grasp. Though we are able to grasp few, some of them are able to grasp more. It was unlimited meals, very nice. But if, as you told, any other session on this parametric, non-parametric, with more number of hours, definitely it will be good treat for all of us.
Yes, sir. That's a very good suggestion. In fact, we have with us Dr. Abhijit Chakravarti, who is the Vice Principal of Global Institute of Management and Technology from Kolkata. He also made a suggestion that let me put it across, that research methodology workshops would be little bit lengthy, as Suresh rightly said. So we'll plan out accordingly, and we'll see the best what we can do it, and definitely we'll do it. We'll take it up. Thank you.
Suresh Kumar sir. Suresh
Yes,
Kumar
sir.
sir.
Yes, sir.
Whenever the mother
Yeah.
think about the children's, always she's trying to feed more. Like whenever my students, whenever my participants, whenever my then again in this class, always I'm trying to give the full meals. But at the same thing, that it's become a negative aspect for me also. Sometimes it's boomerang also.
When we start applying the concepts,
But again, I'm not bothering about it, but I'm trying my level best to give the full meals always. Thank you, sir. Thank you for your complimentary.
Thank you, sir.
Thank you very much.
Thank you, sir.
Bye.
Thank you so much, and good night. Have a great week ahead tomorrow onwards. Thank you once again. Keep in touch.
Thank you, guys. Good night. Bye.
Good
Thank you,
night.
sir. Good night. Bye.